Moving on to the second case study, I'm very pleased to welcome Alex Marshall, who is the Group Business Development and Marketing Director in the US for Clarke Energy, and he will be presenting a case study in London, United Kingdom, entitled King's Cross District Energy Project. So the floor is yours, Alex.
Thank you, Hans. If you could restart my video, that would be appreciated. And I'll just share my screen. Can you confirm you can see that?
Well, we can see you, but not your slides. Yeah.
Excellent. So thank you very much for that introduction. I am currently calling from the UK, although I'm also a European, typically based in North America. I live just outside Boston in Foxborough. So the project I'm going to be talking to you today shares some similarities with the project just discussed. This is in London, another redevelopment area close, just north of the city centre, and a major development in the city. And by way of an introduction to Clarke Energy, we're the largest Yambacker distributor globally. We operate in 27 countries. We help support the transition to net zero. We deliver resilient power generation installations. We help to lower cost and carbon emissions. We're also a turnkey EPC contractor within the scope of supply of the power generation equipment. And we come from after-sales support, so roughly half of our global service, our global team of 1,400 people is service staff. And these are the geographies in which we currently operate. Particularly strong bases in the UK, France and Australia, but also covering India, a lot of Africa and the United States. So we view the position of a CHP engine within a wider scope, and this also should be considered for district energy applications. So the CHP, or battery energy storage, will typically form the anchor of a microgrid or distributed energy solution. The CHP acts as that perfect anchor of both electrical and thermal loads for that microgrid. And then you have integration of wind and solar technologies is becoming more and more common, along with emergency gas and diesel gensets, and then integration of other technologies, including heat pumps and thermal stores. And then again, integration into that scope of supply. If you have a hydrogen requirement or a biomethane requirement, they can be used directly in the CHP or for vehicle refueling. And taking that a step forwards, there are also a number of complementary technologies that can be deployed for district energy networks from CO2 recovery. So there's a range of different technologies that's now used to recover CO2, originating from greenhouses, basic denitrification of the gas, through to much more advanced systems with amine washing to give up to food and drink grade beverage standards as liquefied or compressed CO2. Biogas upgrading, which again can have CO2 recovery for bio-CO2. And we're starting to see advanced carbon capture systems locking up carbon dioxide as calcium carbonate and calcium magnesium carbonate. So we see we act as a reliable single point of contact through the whole process, resilient always on power for your site, and adaptive integration with any existing energy assets. So moving on to the topic at hand is the King's Cross CHP scheme. It's a very, very attractive scheme, mixing the old of the canals and the docks and the gas towers, which you see there on the left, with new commercial and residential buildings. It's a redevelopment of 67 acres total in North London, north of the very famous King's Cross railway station and St Pancras railway stations. It's a mixed-use development that includes commercial and residential buildings. Metropolitan King's Cross, which was our customer, is a joint venture energy supply company between Argent and Metropolitan King's Cross. So they were the ultimate operators of the district energy network and our customers. So this is the scheme, courtesy of Google Maps. So you see in the base of that image the two railway stations serving central London, which have also been recently regenerated. And to the north of those, you see the development area for the King's Cross site. And the CHP scheme is nestled on a very, very tight piece of land in the corner adjacent to high-speed railways. So very little room for any margin of error on this site. As with most things in London, space is of the premium. So the technology, INEO's Yanbacker gas engines, previously a GE product when this was installed. This is anchored in the 612, roughly 2 megawatt unit. It has been installed in 2 phases, with room for a 3rd unit if expansion was required. Each engine can give 2 megawatts of electrical power and 2 megawatts of thermal power, so roughly 4 megawatts and 4 megawatts respectively. The district energy scheme, as a wider scheme, is capable of delivering electricity, heating and cooling, and the measure of appropriate CO2, CHP technology, quality assurance in the UK, was 116, which was 10 points over what was expected for the site. So the project, phase 1, our customer, Metropolitan King's Cross, phase 1 was installed in 2012. The district energy and cooling network was installed by Vital Energy. And according to Metropolitan, the CO2 emission savings was 60% above the baseline CO2. In addition to that, the customer has achieved contracts for the supply of biomethane. So the energy going into it is wholly renewable, as well as delivering those original CO2 savings. Phase 2 was started in 2014 with the next 612 unit. And you may be wondering why everything is bright pink. That was a charitable exercise to raise attention to breast cancer awareness. It's the bright pink of the breast cancer awareness charity. Thank you very much for your time. If you've got any questions at the end, I'll be happy to take those. Thank you.
Thank you, Alex. Thank you for your presentation. Yeah, we'll keep the questions to the end.